In this unit, we will be dealing with measurements and in particular the units associated with the various measurements in the metric system. There are two basic types of units that we will encounter in the standard international system for units, commonly known as the metric system. There are the fundamental units or the base units, and you must memorize these. And then there are derived units, which come from the base units, and you'll become familiar with many of these as we move through the course. There are 7 base units and then a number of other derived units that we will discuss. Shown here are the 7 base units in the metric system. You need to know the physical quantity associated with these measurements and the corresponding name, and then in particular the abbreviation associated with that particular unit. In this particular case, paying close attention to whether the unit is uppercase versus lowercase. This can be confusing if you're not paying attention to those kinds of details. You need to know all of these except for luminous intensity, which is not something that we will discuss to any significant extent in this class, but you may encounter it in more advanced classes. Okay, these are the prefixes associated with the metric system. In this particular case, you will need to have the symbol for the prefix memorized, paying close attention to upper versus lower case, and then also the corresponding power of 10. For example, kilogram is, or kilometer, it corresponds to a K and then lowercase m. This is 1,000 meters, a typical unit for measuring the distance you travel in a car. The prefixes that you must have memorized are kilo, and then centi, milli, micro, nano, and then in addition to that, you should also be familiar with the angstrom. This is a unit specifically of length, and it is 10 to the negative 10 meters. When the exponent is negative, it's a very, very small prefix, and so the angstrom is a typical distance between atoms in a compound. Just a little bit of vocabulary. There are 2 terms that you should be familiar with. The term extensive property and intensive property. And intensive property is independent, hence the prefix in. It's independent of the amount of substance that you have, whereas an extensive property depends upon the amount of substance that you have. Two commonly measured quantities in chemistry are the mass and the length. The mass of an object tells you how much of a substance you have. The typical base unit is kilograms, but you may also measure the amount of grams in the laboratory, and that would be a very common measure of the mass. Mass is different than weight. The mass of an object depends upon just the quantity, whereas weight depends, in addition to that, the gravitational attraction that that object has to some other object, such as the Earth. So, for example, the weight of an object would be different on Mars than it would be on the Earth, whereas the mass of the 2 objects would be exactly the same. We typically measure mass by comparison with other objects, and this is done using a balance or possibly a scale. The length of an object is a measure of of distance, and the base unit is the meter. The common comparison that I will make is to things like the feet or the inches. A meter is approximately a yard, which is 3 feet. In addition, an inch is approximately 2.5 centimeters, so 2.5 centimeters. To commonly You should also be familiar with the 3 common temperature scales. The Fahrenheit scale is one that we use here in the United States. Typically, the temperature scale is compared to the melting and boiling points of water. So you're all probably familiar with the fact that water, normal tap water, will freeze at 32 degrees Fahrenheit and boil at 212 degrees Fahrenheit. And so on the Celsius scale, which is again a metric unit, so typically involving powers of 10, the reference points are the freezing point, which was given the value of 0 degrees Celsius, and the boiling point is then assigned a value of 100 degrees Celsius. The Kelvin scale was devised to avoid the possibility of having negative numbers, and so the 0 point was set at the absolute lowest possible temperature, absolute 0. That then corresponds to the freezing point of water being 700 or 273.15 Kelvin, and the boiling point then is 100 degrees higher than that, because the size of a degree Kelvin and the size of a degree Celsius are exactly the same. You should be able to convert in between these units and have a rough estimate of what these values would correspond to. So, for example, normal body temperature is 98.6. That's approximately 40 degrees Celsius on the Celsius scale. Shown here are the formulas that are typically used to convert between various temperature scales. The conversion of the Fahrenheit to the Celsius and vice versa are shown near the top here. What you should have a good feel for is that if you take a degree Celsius and multiply by about 2, that will be the temperature change on the Fahrenheit scale, taking into account that the 0 point is actually 32 degrees Fahrenheit. The equation you see to the right of that is the rearranged form of that equation. You should be comfortable with rearranging these types of formulas. So, for example, if you were to take the equation on the left, subtract the 32 from both sides, and then cross multiply the 5 and the 9, you can then arrive at the equation on the right. So either one of these equations you may need to use, and should be comfortable with the rearrangements. One that I will require that you memorize is the equation that converts between Kelvin and Celsius. So the temperature on the Kelvin scale is equal to the temperature on the Celsius scale plus 273.15 to account for any significant figures that you might be dealing with. So, you need to commit that equation to memory. And finally, we have an example of a derived unit. derived units come from the base units. A good example of this is area. Area is a two-dimensional unit because area is the length of, say, a square times the length of the second side of a square. And oftentimes then the unit will be represented as a meter exponent 2, which is given the name meters squared. And so that would be the same as a meter times a meter. The volume is a cubic unit because it would be the length of one side of a cube times the length of another side times the length of the third side. And in this particular case, then the unit would be meters raised to the power of 3. Same as taking the distance of one side of a cube and raise it to the exponent of 3 would give you the quantity for the volume of that cube. So you should also be comfortable with converting between the cubic meter and the decimeter cubed. And you should also know that 1 decimeter cubed is the same as the derived unit, which we call the liter. Finally, the one that is absolute must know is the fact that a cubic centimeter is the same as 1 milliliter.